Welcome to Dr. Richardson's class in immersive experience. Let's see what you're learning today.
All right, so we're talking about cells today. And we have done previous lessons about cells, right? So we've had a class discussion, we've had some notes about cells, and now we're going to apply it. We're going to put it in action, okay? And how we're going to do that is by first doing a brain map, right, that kind of organizes the information in your head. I'm just going to turn these on real quick. So it organizes the information in your head so you have a visual map so that anytime you're asked a question about cells, you can just bring up that visual map of cells in your head to know where things go, okay? And then after that, we're actually going to do a real world situation, right? You've been given some scenarios and you had to, with your groups, come up in those scenarios with a diagnosis for a patient, right? And how to solve that problem. Or maybe there's no solution at all, right? We'll see as we do these presentations, okay? But that's what we're gonna do today. That's the plan. All right, and if I can get someone to read the standard for us, Cassidy, if you could read the standard for us.
Compare and contrast the general structures of plant and animal cells. Compare and contrast the general structures of prokaryotic
Yep.
and eukaryotic cells.
All right, cool. I have one more standard. You're gonna read my next standard? I got somebody who, she already said she wanted to read the standard. Yep, I heard it. Okay, go ahead. What's this standard?
Relate structures to function for the components of plant and animal cells.
Okay, so that's what we're doing. We're going to compare and contrast the structure of prokaryotes and eukaryotes and the structures of animal and plant cells, and then we're going to talk about the function when we do our real world scenarios. All right, here we go. So you're going to be split up into teams. This is team A, this is team B. All right, you're going to go up to the board to fill in this brain map using the information, the template that I already have. All right, so I've got, the first thing is type of cells, right? And so there are two types of cells, and you have to tell me what those two types of cells are. The words are on your table. You have to work together as a team to figure out what words go where. So let's do that first one now, team A and team B. There are two types of cells. What are those two types of cells? Okay, you don't have to tell me out loud. Use the words. Use the words on the table and go put them on the board.
Okay, come on, guys. Let's go.
Have a great day.
Let's go, guys.
Yep, good job. Grab a magnet. Oh, put it on the, I got you. Yeah, put the word over, put the word on first. Yeah, thank you. I appreciate it. Good job. Teamwork makes the dream work. Yeah, that's it right there. All right, good. Good job. All right, so team A got prokaryotes and eukaryotes, and team B also got prokaryotes and eukaryotes. Good job. You both got that right. All right, so now let's move on to the next tier, organisms, right? So what organisms would be considered prokaryotes and what organisms would be considered eukaryotes? Bring it up to the board if you know what it is. Bring it up to the board if you know what it is. On the left. Under organisms. Okay.
You know what putting that? Right here. No, not you. Oh, my bad. I'm sorry. No, stop putting one right here.
Drop one. Oh, yeah, I hear it. You said it. Yep, you're right. Are we allowed to? Hold on. Wait, we're allowed to. All right. Let's see what we got. Are these final answers? Final answers? We're good? We're locked in? Okay. So Team A got archaeobacteria and bacteria for prokaryotes. And for eukaryotes, they got fungi, animals, plants, and protists. And Team B got the same. Bacteria and archaeobacteria for prokaryotes, fungi, protists, animals, and plants for eukaryotes. Both teams are right. Good job. All right. Yeah, good job. Good job. You can give yourself a round of applause. All right. Let's talk about differences. What are the differences between prokaryotes and eukaryotes? Pro rhymes with no, and eu rhymes with those are hints. Those are hints. Put what goes there. What don't prokaryotes have that eukaryotes do have? What are some things that prokaryotes don't have that eukaryotes do have? Yep, you got it right here. Yep, that's perfect.
This is for prokaryotes. For prokaryotes.
No, this is under similarities.
Good job.
No, eukaryotes.
For plants and
Yeah. Oh, we can't do that. Yep. That's eukaryotes on that side.
it has a nucleus and membrane around organism. So it's wrong. And it shouldn't it be membrane bound organisms? And that would be
Yeah, there you go, Ayana. That's right.
hey.
All right. Let's see. Team B for prokaryotes. You've got no nucleus, no membrane-bound organelles. Good job. And for eukaryotes, you've got a nucleus and membrane-bound organisms, or organelles, sorry. And yep, same thing for Team A. You've got the same thing. So good job. You guys did good with that too. All right. You know your stuff. You know your stuff. All right. Let's talk about similarities. Let's talk about the similarities. What do prokaryotes have that eukaryotes also have? What do they have in common? Get some words that they have in common.
Words they have in common?
Yeah, what organelles do they have in common?
Similarities?
Similarities. Yeah, I hear it. I hear the conversation. Good job. Good job.
Do those all have? Yeah, you do this one. No, it's the other one. It's the other one right there. In the middle. Take this off the cell wall. No, it's the other one. Yeah, that's the song to say. That means the body, right? That's this animal.
Oh, yeah. You figured out you were missing something. Yep. I see you guys. You guys are good. All right. Team A is finishing up.
I think we won.
That's right.
It said no milk. It said no milk.
Oh.
On video.
All right, are we ready? We're good? Final answers, team?
Yes.
Yes, you guys agree on the side?
Yeah.
Okay, all right, let's see. Let's see what we got. You want me to start with Team A or Team B? Team B? All right. Team B. Similarities for prokaryotes and eukaryotes. You've got DNA, cell membrane, cell wall, cytoplasm, and ribosomes. For Team team A, you've got DNA, ribosomes, cytoplasm, and Golgi apparatus. So we've got a fork in the road, right? We've got a difference right now that we haven't had yet. So let's see. Team A, is there anything that you want to say about Team B? What do you think about what they have?
Well, prokaryote says no membrane-bound organelles, and eukaryote says it does have membrane-bound organelles, and in the middle it says cell membrane.
So you're thinking that the word cell membrane that they have up there, the organelle cell membrane, is wrong because it has the word membrane, and you're saying prokaryotes aren't supposed to have a membrane? Is that what you're saying?
Sure.
Okay, she's for sure. Does anybody over here want to defend what they had? No, you just like, you just know. You just know you're right, Kathleen.
Golgi apparatus is not supposed to be on there.
Okay, all right, let's do this. Let me tell you. Cell membrane bound organelle, right, is an organelle itself, not the actual membrane. So like, the organelle, right, so this would be the cell membrane, and then the organelle would be what's contained inside the membrane, right? So this whole thing would be considered a membrane-bound organelle because it has things that are contained inside of it.
Okay,
does that make
cell
sense?
holds it.
But the cell membrane just holds it. So they all have to have a cell membrane because they all also have this jelly,
Okay.
right? And if it didn't have something holding it, then that jelly would just be everywhere, right? So it has to have something that contains it. So you're right that there are no membrane-bound organelles. Like Golgi apparatus is a membrane-bound organelle. It actually looks folded, kind of like this. Sorry, you know I can't draw, right? So this outside of it would be the cell membrane, but what is contained inside, right, would make up a membrane-bound organelle. Does that make sense?
Yes.
Okay, all right, cool. So Team B is actually correct. I'm glad you guys had this discussion, though. I'm glad that we were able to have this discussion, so that's good. All right, go ahead, Team A, and put your words, the rest of the words that belong up here. So you've got cell wall, right? Cell membrane. Those are the two that you're missing, cell wall and cell membrane.
Right here.
Good job.
Is that one? Cell wall up there.
Oh, wait. No, we're good. No, we're good.
Okay, right there.
Yes, you're good.
I have a headache. Just the perfume. No.
All right. Last thing I want to talk about, last thing our standard talked about was plants versus animals. I'm just going to adjust this a little bit. These are right, but I'm just going to adjust it so that we have distinction. All right, so we're talking about plants versus animals now. You're going to tell me what plants have that animals don't have. Okay, what do plants have that animals don't have? All right, go ahead. Work together with your group. Tell me what plants have that animals don't have.
Plants have leaves, but animals don't have leaves.
Oh, they have garb buddies. I think I got cell wall.
Why I put that? Why I put that? You want me to say? No, that was highly interactive.
That's it. That's good.
You said differences?
Yes, what are the differences? The differences. We'll get to the similarities in a minute.
Plant. I mean, animal. Yeah, right there. No, not right there. The other one. No.
That doesn't make you any more straight.
Yeah. No.
No, that's okay, right here. Just put it right here. It's fine.
Oh no, this is
Good job. animals. Oh, so you did the differences for plants. What about the differences for animals?
Differences for animals.
Y'all back there.
Okay.
Animals have
Okay.
skin.
I'll take it.
What's this be wrong, bro?
Nope. Those animals don't have skin. Oh my god. Wait. My bad.
Animals have life.
Oh, Lester, I see you. I see you.
You cooking, I tell you how you cooking.
He's cooking.
Yeah. Animals have this.
What about this?
Oh, I see you, Yana.
Alright, y'all, put this up there for animals.
Say please.
Wait. Yeah.
I'm just gonna move it under. Yeah, take it. Stop. I'm just moving it down.
What is
We're just doing differences for now. We'll move on to similarities in a second. All right. Good? All right, you want me to check it? You guys ready? Just check it. It's up to you. If you're not done, I want final answers.
She's smelling But who done the Richardson? Yes.
All right, we're ready. These are final answers?
Yeah.
Okay. Team B, you are missing one thing under animals. Team A, you're missing one thing under animals. Can you figure out what it is? One
But it might be
thing under animals.
Rimazone.
Oh, on the animals?
Yeah.
For which one? Similarity.
Oh! Difference.
Here. Wait for difference.
Good conversation.
Yeah. You don't want to listen.
You're done?
Yes, ma'am.
Oh, no. I don't put it on.
We finished. You finished.
Yeah, we're trying to see what we know. We got it. I got a little prize, you know.
I heard prize.
I got a little prize for you. Okay. All right, so let's see. Team A, for plants, you got chloroplast, cell wall, large central vacuole. That is correct. And Team B, for plants, you got chloroplast, large central vacuole, and cell wall. Good job. And for animals, you got microtubules, lysosomes, few small vacuoles, and centrioles. And Team B got the same thing. Good job. So you guys figured that one out. All right, the one that you were missing was centrioles. Both groups were missing centrioles until you figured that out. Let me ask you something else. Why do you think plants have a large vacuole and animals have small vacuoles? Do you remember what vacuoles do?
Because
They store water.
plants they store water and animals get water. So they don't
Okay, all right.
Yeah.
plants don't get water every day.
Plants need more storage than us.
There you go. All right, good. Yeah, I'm hearing good answers. So, you said vacuoles, right? Because vacuoles store water, right? And you said plants need more of that storage than animals do. And you even stated, like, if you go out of town and you water your plant, you can be gone for like 5 days and you come back and your plant won't necessarily be dead, right? Because it has that stored up water that it's going to use. So it needs a larger vacuole. Let me ask you something that helps you, that would help you remember about lysosomes. What word do you remember for lysosomes that helps you remember? Lysol, because what does Lysol do?
Clean.
And what do lysosomes do?
Clean the cell.
Clean the cell. Good job, guys. All right, one last thing for this activity and then we're moving. Similarities. Tell me the similarities, and those should be easy because it should be everything that's left on your table, right?
Yeah.
It should be everything that's left on your table.
You should have had like a little trick.
A little trick, added some words. Yeah, that would have been good, Lester. That would have been good.
Wait, what the same with plants?
Yes. What do plants and animals have that are the same?
Where does it
Similarities. I'm giving it right in the middle. Put it in the middle right here.
No, right here.
Oh, okay.
I'll move this.
No, not right here, though. Right here.
Just put it in the box.
This too, right?
Dr. Richard, you got some more. You got some more.
Some more magnet? It's here. Oh, yeah, Ayana's holding some.
Y'all trying to get bougie? Look at them little peas.
Her chair?
Her chair? How do you break it so perfectly, though? That's so interesting. Like a puzzle. It was a small.
Izzy was here.
Oh, I got the other two.
I haven't seen you since.
Is this one I like this?
That goes in?
In the middle. I know it's crunched. Just try and fit it in. All right, we got them all up. So what's similar about these is smoothie are, roughy are, nucleus, cytoplasm, mitochondria, ribosome, cell membrane, and Golgi apparatus. Good job, good job. These are also membrane-bound organelles. All right, these are your membrane-bound organelles, except for cell membrane, it's the membrane itself. All right, good job, guys. Oh, and ribosomes. Let me say that. Ribosomes are also not a membrane-bound organelle, but the rest of these are. Okay, so ribosomes and cell membrane are not. All right, let's have a seat real quick. Have a seat real quick.
Rats.
All right. So, yes.
You can't take it.
Here, I'll take it. Okay, got you. Thank you. Okay, so right here. So, with this activity, you were biologists, right? So now we're about to go from biologists to medical doctors. Okay, we're about to look at some. You already looked at some scenarios and came up with some ideas of a diagnosis and a solution, right, for that diagnosis. Okay, so let's go ahead and present those. When you come up, if you would just introduce yourselves, right, by your last name, because you're doctors, right? So I want like Dr. this, Dr. that, Dr. Williams, right? Let's do that, okay? All right, go ahead. Let me get. Who wants to go first? Do I have people? Anyone who wants to go first? You want to go first? Okay, let's go. You want to go second? Okay, I got you. Make sure you present your patient. Hold on. Lock in, everybody lock in. Lock back in.
I'm Dr. Harrison,
And I'm Dr. Williams.
and our patient is Davion.
Davion is in the clinic for a checkup. First diagnosed him with Treacher-Collins syndrome, a genetic disorder that affects the development of the bones and other tissues in the face. TCS is believed to cause a change in the gene on chromosome 5, which affects facial development. About 40% of the time, one parent has Treacher-Collins syndrome. The parents are not affected by the syndrome. The chances of having a sibling having Treacher-Collins are minimal. So the organelle that's responsible is the nucleus, because that's where the DNA and genetic material is.
Okay, so do me a favor. Just in, it's what we call layman terms, right? Doctors say layman terms, which just means in common terms. Tell me a little bit about, I know you read it, but tell me what Davion's issue was. What is going on with him?
He had a genetic disorder.
He had a genetic disorder called Treacher-Collins syndrome, right? Okay, and so what's your diagnosis? What's wrong with him? Did you say it, Dr. Harrison?
It's in his nucleus.
It's the nucleus. And why is it the nucleus?
Because it stores the DNA. That's where the DNA is stored at.
Okay, all right. Do you remember, let's just go back a little bit. I'm going to ask a question, and anybody can answer, okay? I'm just going to go back a little bit. We have already done a lesson on macromolecules, right? So let's tie macromolecules in with cells to make it relatable, okay? What macromolecule does DNA fall under? Do you remember? I heard. Say it again, real loud. Nucleic acids. Nucleic acids. Is there a solution for this patient?
No. There's nothing you can like physically eat or take to, because it's in a cell. It's a nucleus. It's a nucleus.
Okay.
And you can't really change like DNA in this.
Okay, yeah. All right, good. There is no simple solution for Davion because it is genetic, right? And so that's exactly what you're saying. It's genetic. It's in his genes. There's not something simple like a food that he can eat to fix it. All right, good job, guys. Dr. Williams and Dr. Harrison, good job. All right, go ahead. Next group. Introduce yourselves, doctors.
My full name, professional.
Go ahead.
Patrick Green.
Dr. Green and?
Dr. Green. Dr. Green.
Dr. Norris.
And Dr. Norris. Okay. What's your patient's problem?
Alex was brought into the clinic by his football coach. The coach stated that Alex is delirious, has intense cramps, and has been vomiting since he had drank over 1,000 milliliters of water under 45 minutes at football practice.
Normally, the sodium concentration inside the cell is equal to the sodium concentration outside the cell. However, drinking this much water in a short amount of time will cause the inside of the cell to become diluted. To compensate, water from outside of the cell will rush into the cell, causing water intoxication, which cell organelle allows to happen.
So what do you think the diagnosis is? What organelle is the problem?
The vacuole, he drank too much water, so the vacuole can't release it.
Okay, the vacuole could be an issue. Some of his vacuoles could be an issue. Do you guys remember what, first let me ask you, is there any other organelle that you came up with besides the vacuole? Is there anything else you thought about besides the vacuole? Who said lysosome? You said lysosomes. Why do you think lysosomes, Anna? Why do you think lysosomes?
It's supposed to clean up every time you leave operation.
It's supposed to clean up, and you're saying their scenario said something about intoxication.
Yeah.
And so you're thinking it's maybe not detoxifying for lysosomes? Okay, that's a good guess. There's something else too. What allows there to be balance? It allows things in and out of the cell.
Golgi apparatus.
That's packaging. That's packaging and transporting.
I know this one. Hold on.
It allows things to enter and leave the cell.
UPS.
The cell what?
cell wall.
Not the wall, but the cell. The cell. Good job. Good job. Okay, cell membrane. So the cell membrane could be an issue too because it is what balances the cell out. And so it's saying there's a problem with the sodium potassium pump, right? All right. Good job. Good job, guys. Good job. All right. Who's next?